So let us continue with chapter 12. Value stream mapping, VSM in short, is a special type of flowchart. So it's a special type of flowchart, and it is used to analyze whether the value is being added or not and where the value is being added as materials flow through the process. It is actually useful for developing lean processes. So let's take a look at the manufacturing process map. So this is the manufacturing process map. If you go to a company who does manufacturing, you would often find something like this because they would like to show the processes that are involved. So what we have here is the supplier, and then we have the customer, and then we have production control. So all the activities that are done between what the customer wants as forecast for the production control and how the monthly forecast to the suppliers are given so that you can get weekly orders is shown here. They also show all the factors that are involved in this, lead time, cycle time, work time, and all that. And they would also show for each machine what are the different factors that affect that. Whether it is what is the uptime, which means basically in this case the inspection machine is 99% uptime. It is almost up all the time. Whereas this machine is up 87% of the time. And also it tells you the available capacity. It tells you what is the lot that they're going to be using for purchasing and all that, cycle times and all that stuff. Everything is given here. So this pretty much shows also how many pieces per month are being produced and how many pieces per day, how many containers per day are being shipped. All these things are also shown. This gives you the entire way of what manufacturing or production is done in this company. This gives you a snapshot of everything. It also gives you how the shifts are, what is the time for lunch and breaks, and what is available time, everything. So this pretty much gives you the important factors of the manufacturing process in a company. And this is a manufacturing process map. The value stream mapping is done using these symbols. For customer or supplier, you see this. See this? It's the same thing. Processes are denoted by this symbol. Like, for instance, if there is a process here, it's going to be shown. A process here is shown like this. And shipments are shown as arrows. Material pull is shown by this arrow. Work cells are denoted by this. Data boxes are denoted by this. For instance, you can see those data boxes here. So all these are mapping symbols that are pretty much used to show the process. And these are, by showing these processes, they can also say, hey, these are the potential areas. You can identify the potential areas for improving the process. For instance, this whole thing of machine, the supplier to the machine, it can be replaced by designing a design Kanban. And we're going to be talking about what is a Kanban in a few minutes. So Kanbans are events that take place in manufacturing companies. These events are to reduce waste, to make lean the lean as the promising factor, and using lean principles, you can get better efficiency and effectiveness for any process. Those are the activities that are called Kanban activities. The lean supply chain design principles include layouts, which are lean, production schedules that are lean, supply chains, which are lean. One of the things in lean layout is the JIT, which is just in time production. I have included a video for you to look at, so please look at that just in time video to understand what is just in time and how companies use this just in time. The lean concepts basically requires a good plant layout to be designed so that you have a well-balanced workflow with minimum work in process inventory. It also wants to look at preventive maintenance, periodic inspection and repair to make sure that the equipment is reliable and this uptime of the machine is high. Those are the lean concepts that are important. The other lean concepts that are important would be that there is something called group technology. This is a philosophy in which similar parts are grouped into families. For instance, if you're having screws of different dimensions, like half inch, quarter inch, 3/8, all these are children of a parent called screws. So you have a family now of screws that you can pretty much buy and procure and make it effective procurement. Similarly, that same philosophy is also done when companies like Ford and GM and Chrysler, when they manufacture cars, they look at chassis. Sometimes it's called Class A, Class B, Class C, Class K. Those kind of chassis are written as families. So it'll be easy for them to procure. And it'll be effective for them to procure because they're procuring a family of parts. They're not making 100 different parts. It'll be 1 or 2 or 3 different parts, and everything else that they do belongs to the same family, of one family or other. Those are the lean concepts that we want to look at. The quality is important. Quality at the source is important. So the basic premise to this lean is do it right the first time. And when something goes wrong, stop the process or assembly line immediately. Actually, this is very interesting. Companies like Toyota, every worker can stop the whole process or the assembly line immediately whenever they want to. Of course, they're going to see whether they should do it or not first, and then they are held responsible. So workers are personally responsible for their quality. Therefore, they can, if something goes wrong, stop the processes also. So workers become their own inspectors. Workers are empowered in many of these companies so that they can do their own maintenance and housekeeping until the problem is fixed. So this brings the efficiency because they take the ownership of this, and they're taking a ownership, so the employee is responsible, so the person is going to get paid more, so he is motivated and incentivized and all that. So there is a good quality at the source, and that is the basic principles, fundamental principle of many of these highly efficient manufacturing companies. Just-in-time production is producing what is needed when needed and nothing more. So if a car chassis comes to a stop or if it continues through a work cell where they need to assemble wheels, only 4 wheels need to be there. and those four wheels will be there. When the car passes that, another four will be brought, so that when the next car is coming to be assembled, those four wheels will be there. That is just in time. Anything over the minimum amount necessary is viewed as waste. We think about ideal lot size or production batch. Vendors ship several times a day to their customers to keep lot sizes small and inventory low. So for this, Ford basically, for instance, the assembly plant in Chicago, Ford assembly plant in Chicago, which is outside Chicago, many of their suppliers are about 20-30 miles radius max. So there is a company called Lear Corporation, which does many parts for Ford. They are on Indianapolis Boulevard in Indiana, where Ford is outside, is in East Chicago. So they're very close to each other. And that's how the vendors can ship several times a day, because as Lear produces 10 or 15 parts, they can put it into a truck and send it to Ford, which will take about 15 minutes. And then as Lear produces the next batch, it's sent as the next batch, and so on and so forth. This is JIT, or just in time. Inventory actually is, as we talked about, is of utmost importance because of it's considered as an asset. It goes to the balance sheets. So it is a very important part of a company. So inventory basically gives raise to good products, and also improper management of inventory can breed productivity problems. This is like tip of the iceberg when we talk about machine downtime. Oh, this machine is not working. That is just the tip of the iceberg, because you can see that there are a lot more problems which are below that. So to go through all these problems takes time. So these are all the productivity problems because of inventory. So inventory basically hides these problems. So you need to be careful on inventory. And that's why many of these companies spend a lot of time on control of inventory. Lean production schedules, or one is pulls material into final assembly at a constant rate. The period of time during which the schedule is fixed and no further changes are possible, it's called freezing windows. And smoothing the production flow to dampen schedule variation is called uniform plant loading. Calculation of how many of each part required to produce the actual quantity is called backflushing. These are some of the lean production schedules. Kanban is a production control system, and please watch a video that I've uploaded on Kanban. Kanban means sign, a placard, or an instruction card in Japanese. Kanban came from Japan, from Toyota. It's basically a signal that is used to control production. So let's say you have it's called a pull system, and you have a rack with one product, two products, three products. As you take one product, there is something which shows up here saying add one more product. That is Kanban. That is a pull system. So worker takes the first part A from a full container. Worker takes the withdrawal Kanban from part A and takes the cart to the machine center storage area. Worker finds the container of part A, removes the production Kanban, replaces it with the withdrawal Kanban, and then the cards come back to the dispatch list for the machine center. This is how Kanban works. So look at the video that I have showed. This pretty much shows the entire control system, or the pull control system of Kanban. flow of Kanbans are pretty much where